This is lecture 12 in signals and systems. Now in this lecture we are going to do some problems on systems, that is how to identify the given system is linear, non-linear, memoryless, with memory, etc. In lecture 11 we have discussed the classification of systems. Right, in this classification system we have seen what is a memoryless systems and with memory, right? So memoryless, or we can say static, and it is dynamic systems. Similarly, linear and non-linear. So we have seen the procedure to find how a system can be set a linear and non-linear. Similarly, time invariant and time variant, causal and non-causal, right? And we have seen invertibility and inverse systems, right? So if a system is invertible, then it will have inverse systems, right? This we have seen. Now we will see some problems how to identify, right? So this is the question given, so we need to see is it memoryless or with memory or without memory, linear or non-linear, etc. First one we see, is it a memoryless or and with memory. So we have seen it is which one of this one. Now I told you substitute t is different values. If y of 0 by substitute, it will become minus infinity to 0, because in place of t we need to substitute 0, and this is x of tau d tau. Now if you observe, for t equal to 0 we need to integrate the x of tau or x of t minus infinity to 0. That means it is depending on the past values of the input. So it is not a memoryless system, or with memory system, or it is having a memory. So that's why we can say it is not a memoryless system, or we can say with memory. So that is very simple one. Substitute t equal to 0 or to 1 and see if present inputs depend on the present output, then we can say it's a memoryless. But it is depending on the past inputs, right? Minus infinity to 0. So that's why it is not a memoryless, or we can say with memory system. Next we see if the system is a linear or non-linear. So linear or non-linear. Now there is a standard procedure, but we can say directly all integration or differentiation, or we can say linear, but by the procedure we will find. So once we find that, it will be remembered. So the procedure is for x1 of t, what is y1 of t? So minus infinity to 2t x1 of tau d tau. Similarly, for x2 of t, we find y2 of t, which is minus infinity to 2t x2 of tau d tau. Now what is the next one? We will assume x3 of t as the summation of the x1 and x2 with some coefficient, so b into x2 of t. That becomes y3 of t is equal to minus infinity to 2t. In place of x1 x2 we will get x3 of t, and if we replace x3 of t like this, a into x1 of tau plus b into x2 of tau, right? Now we can easily split the integration, so it will become a into minus infinity to 2t x1 of tau d tau plus integration b minus infinity to 2t x2 of tau d tau. If you see, this one is y1 of t and this one is y2 of t, so we can write a into y1 of t plus b into y2 of t. That means so this y3 of t we can write as a into y1 of t plus b into y2 of t. So it is satisfying the superposition principle or theorem. Then we can say the system given is linear, right? So the next one we have to see the time invariant or time variant. Right? Now we will see that is time invariant or time variant. Now given expression is y of t is equal to minus infinity to 2t x of tau d tau. By seeing this limit we can say directly that it is time variant. Reason is, I told you in the previous lecture that if y of t is equal to some x of 2t, that is scaling is there, then we can say directly the time variant, right? So the moment it is in limits it is having 2t, it is a time variant, but I will prove with the procedure. What is the procedure? x1 of t, so we will get y1 of t as minus infinity to 2t x1 of tau d tau. Next we need to assume x2 of t is equal to some delay in the x1 of t, so x1 of t minus t naught. For x2 of t, what is y2 of t? y2 of t is equal to minus infinity to 2t x2 of tau d tau, but x2 of t is this one, so in place of t we are having the tau, so it will become minus infinity to 2t x1 of tau minus t naught d tau. So here we should get a single variable, that is either a tau or t or k. So this tau minus t naught we will assume some k, right? So what will happen to tau? Tau is equal to k plus t naught. When tau is equal to minus infinity, k is also minus infinity. When tau is equal to 2t, what happens to k? 2t naught plus, so it's just 2t, right? So 2t plus t naught. So these are the limits of k. This is minus infinity to 2t plus t naught, right? These are the limits for tau. Now what happens to tau minus t naught is equal to k? What happens to d tau is nothing but dk. T naught is a constant, it will be 0. Now the limit is replaced by minus infinity to 2t plus t naught, and this will become x1 of k dk. This is the y2 of t, right? Next, this one is over, so I will take it as this one is expression 2, this one is expression 1. Now what we need to do? We need to time shift the y1 of t. So from equation 1, if I shift y1 as t minus t naught, what happens to integration? So integration minus infinity to, here we are having 2t, so in place of t we are substituting t minus t naught, so it will become 2 into t minus t naught, and this one is x1 of tau d tau. See, this one will be same, because this is a one variable, this is different variable, right? But if you see this limits, this is 2t plus t naught, but this is 2 of t minus t naught, which is not equal, right? Then we can say y1 of t minus t naught is not equal to y2 of t. So it is what? Time variant or not a time invariant system, right? This is about this one. Next one we'll see the d, stable or unstable. So we'll comment on the stability. So stable and unstable system. Now equation given is y of t is equal to minus infinity to 2t x of tau d tau. So what we need to assume? We'll assume some bounded input, right? Suppose if I assume some bounded input as x of t is equal to u of t. U of t is nothing but from 0 to infinity the amplitude is 1. So at infinity the amplitude is also 1. So it is a bounded input. Now if I apply this one here, see if I integrate the u of t, so we have to integrate from 0 to 2t, and what is the x of tau is nothing but 1 d tau. So what we will get? We will get tau which is 0 to 2t. So what is this? This is a 2t for t greater than 0. Now remember this is like a ramp signal, right? So which is unbounded. So if I draw the diagram for this 2t, so it will be like this, right? This is y of t, so which is unbounded. At infinity we will get infinity, so it is unstable system. It is unstable system, right? Because bounded input leads to unbounded output, so that's why it is a unstable system. Next we will see the given system is a causal or non-causal. So what is the expression given? Y of t is equal to minus infinity to 2t x of tau d tau, right? Now what is the procedure? We need to substitute y of 0, so our different values, minus infinity to 0 x of tau d tau. If you see this one, so this is the present output. Now it is dependent on the present as well as the past, but we cannot conclude now because there is a term 2t, right? Now if I assume t is equal to 1, it is becoming minus infinity to 2, because t is equal to 1, it is becoming 2, which is x of tau t2. Now if we see this one, present in outputs depend on the future input, right? So this is a anticipating systems, or we can say simply it is a non-causal system. Remember, whenever you are having some scaling factor or some square root or etc., don't conclude for one value. We have to go for 2-3 values, 0 value, positive value, and we can go for negative value also, minus 1 or minus 0.5, etc., right? When the moment scaling factor is there, don't conclude for one value, go for 2-3 values, then conclude, right? We have to see that is there any feature value of the input is depending to get the output, right? So that's why this is a non-causal system, right? So next we'll see one more problem on this. Now we'll see one more problem on these systems. So identify the type of system: memoryless or stable, unstable, linear and non-linear. Now first always we'll see the memory. So is it a memoryless or memory? So about memory we'll see. Now the moment you see this expression, we can say directly it is a with memory, because if we substitute y of 0, this is 0 and it is depending on the minus 2, right? Or we can say if this is 2, this is x of 2, it is x of 0, because for t less than 0 the y of t is directly 0, right? So that means t less than 0 we should not take. If we take, this is some y of t like this, this is y of t equal to 0 when t less than 0, right? So this is 0 when t less than 0, so y of t is directly 0. For t greater than 0, we will get x of t plus x of t minus 2. That's why always we need to see the t value should be greater than 0, right? So y of t, so that is y of 1 if I take, so it will become x of 1 plus x of minus 1 when t greater than or equal to 0. Anyway, it is depending on the previous input. So it is with memory system. So with memory system, right? Now the next one is we'll see about linearity. So there is linearity concept. So it's very simple. So directly y of t is proportional to this x of t plus x of t minus 2. If you follow the procedure, then we will get it's a linear. So it's a long procedure, so no need to do anything because it's directly proportional. There is x of t plus x of t minus 2, right? If you follow the procedure also, so you can get same, that is y1 of t is equal to x1 of t plus x1 of t minus 2. Similarly x2 of t plus x2 of t minus 2 and so on, we will get the linear. Next we will see time invariant or variant, right? So time variant or, so time concept we will see time invariant or time invariant. So carefully see y of t is equal to 0 when t less than 0 and it is depending on x of t plus x of t minus 2 when t greater than or equal to 0. See, y of t itself is changing with respect to time, right? One time it is not depending on anything, and one time it is depending on the input. So from this we can say directly it is a time variant, so no need to do, because when t less than 0, y of t is 0. It is not depending on the input. When t is greater than or equal to 0, it is depending on the input. So y of t itself, it is varying with the time. So it is a directly time variant. Next we will see causal and causality. We will see. So y of t is equal to 0, t less than 0, x of t plus x of t minus 2. Again, if we see the expression, we can directly, it is a causal, because if I take y of 0, right, so it is 0 anyway, and this is x of 0 plus x of minus 2 when t greater than or equal to 0. That means the 0 at the present input depends on the present as well as the past. If you see y of 2, then it is 0 anyway, t less than 0, and this is x of 2 plus x of 0. T is greater than or equal to 0. So again, it is depending on the present as well as the past. So the system is causal, right? Next one is stability. So again, we can say it is a stable only, stability, right? Because see here, it is depending on the x of t plus x of t minus 2. That means if x of t is bounded, suppose again if I take x of t is equal to u of t, so again we will get this is y of t is equal to 0 when t less than 0, and this is u of t plus u of t minus 2, t greater than or equal to 0. If we add u of t plus u of t minus 2, we will get bounded output only. So the given system directly, it is a stable, right? So this is about the properties, right? Next we will see one more problem in the same way, but in place of t less than 0, now it is x of t less than 0, x of t greater than 0, right? So again we can say it is a with memory, because anyway it is depending on the present as well as the past. So by looking the circuit, we can say it is with memory system. See, when you do some 4 to 5 problems, by looking you can easily tell is a memory or without memory, causal, non-causal, etc. Similarly, for x of t less than 0, output is 0. For x of t is greater than or equal to 0, output is this one. So we need to see all x of t is greater than 0 means the values of the x of t is always will be greater than 0. That is the meaning. So for causality, if I take y of 2 or y of 3, it is depending on the future values, right? So x of 2 is less than 0. This is x of 2 plus x of 0 when x of 2 is greater than or equal to 0, right? So anyway, it is depending on the present to present, and it is sometimes past also. Anyway, we need to see x of 2 is greater than 0, right? So it is a causal system only. It is a causal, right? Next one is linearity. So by looking also we can say it is a linear, right? Because whenever x of t is less than 0, we are getting 0. Whenever x of t is greater than or equal to 0, we are getting this summation. So we can get, let's say, the system is linear, right? You can follow the procedure also, you will get the same. Next one, time invariant and time variant. So time variant and time invariant. Previously, if t is less than 0 and t is greater than 0, it was time variant. Now see, if itself the input is varying now, right? So that means if input is varying, output also varying. That means it is a time invariant. So it is not depending on the time invariant. So reason is x of t is changing, so y of t is changing. X of t is changing, again y of t is changing. So that is the reason it is a time invariant. So linear is over time invariant, causal with memory. Again stability. So there is no doubt it is a stable system, because if a bounded input is given, so we have to add only this. So it is a bounded input, bounded output, stable system, right? So this is about the problems on these systems in continuous time, right? So I have uploaded the problem sheet on our blog, right? So So go to that blog and download it and do the problems. Suppose if you are not getting the correct answer, or if you are having any doubt, so please post a comment there, then we can discuss there, right? Next we will see discrete time systems, right? So how to find the same system properties. So but he is given y of n is equal to even of x of n minus 1, right? So x of n minus 1 is there, then we have to find the even of x of n minus 1. We know that x even of n is equal to x of n plus x of n minus n by 2, right? So same signal and reverse of that signal by 2. So x of n is same, x of n minus 1 plus x of, in place of n will get minus n minus 1 by 2. This is the even function. Now for this function we need to see, is it a memoryless or with memory, etc. So first we will see the memory. Now see this. So y of n is equal to, this is the function now, x of n minus 1 plus x of minus n minus 1 by 2. Now simple, y of 0, so it is depending on the future and present. See, the x0 means it is past, so it is depending on the past, and this one is minus 1 by 2. Similarly, if it is minus 1, and it is, see, if you see, this is x of minus 2 plus x of 0 here by 2. Now see, this is present, this is the future value. So anyway, it is depending on the present as well as the past as well as the future. So we can say this is with the memory system, with memory system, right? Next we will see linear and causal. So first we will see the linearity. So we can say directly it's a linear only, but anyway we will find x of n minus 1 plus x of minus n minus 1 by 2. So what is the procedure? For x1 of n, y1 of n is equal to x1 of n minus 1 plus x1 of minus n minus 1 by 2. Similarly, for x2 of n, what is y2 of n? x2 of n minus 1 plus x2 of minus n minus 1 by 2. Now what we need to do? We will assume x3 of n is equal to a into x1 of n plus b into x2 of n. So for this, what is y3 of n? So x3 of n minus 1 plus x3 of minus n minus 1 by 2. Now we have to replace x3 of n one time here and one more time. So x3 of n minus 1. So what is x3 of n minus 1? A into x1 of, in place of n we will have to substitute n minus 1 plus b into x1 of same n minus, so x3 of n minus 1, right, x3 of n minus 1, x1 of n minus 1 plus, now see, in place of x3, so we have to again put this one, so a into x1 of minus n minus 1 plus b into x1 of minus n minus 1 by 2. So what is this? So you can replace a into x1 of n minus 1 plus, so if I take x1 of n minus 1 common here, so see this, x1 of n minus 1 plus x1 of minus n minus 1 by 2. So if I take a common, x1 of n minus 1 plus, here also a is common, x1 of minus n minus 1, this is by 2 plus b, if I take common, x1 of n minus 1 plus x1 of minus n minus 1 by 2. So what is this? Simple, a into y1 of n plus b into y2 of n. So this is y3 of n. So it's nothing but linear system, right? Next we will comment on the causality. Causality. Now y of n is equal to x of n minus 1 plus x of minus n minus 1 by 2. So I am going somewhat faster because it's very simple. Y of 0 is equal to x of minus 1 plus x of minus 1 by 2. Simple. If 0 is depending on the past, this is also past, so we can say causal, but anyway we will see one more, that is positive value. This is x of 0 plus x of minus 2. Again it is past and past. Suppose if I take minus 2, suppose the part, so it is become x of minus 2 minus 1, so minus 3 plus x of, see, minus 2 minus of minus 2, so 2 minus 1, so it is x of 1. Now see, the present, that is minus 2, depending on the future, right? So that's why it is a non-causal system, right? See, previously I told you, whenever there is a scaling, so don't see when the one or two values, always see zero value, positive value, negative values. For negative values, we are getting the output is depending on the future, that is 1, so it is a non-causal system, right? Next one is linear, time invariant and variant. So time concept, we'll see time variant or time invariant. So y of n is equal to x of n minus 1 plus x of minus n minus 1 by 2. I told you the blind rule. The moment it is having some scaling factor or reversal, directly it is time variant. If you follow the procedure also, you will get the same. So there is no need of doing the procedure again. I have given already so many times. Whenever you are having scaling factor or a reversal, so we will get time variant only. What about stability? So stability is simple. If I give the bounded input, we will get bounded output. There is no doubt at all. So if I take x of n is equal to u of n, so bounded input. What is y of n? U of n minus 1 plus u of minus n minus 1 by 2. So this is a bounded output only, so we can verify. So bounded input, bounded output, stable, right? So non-causal, time variant, stable system, and it is also with memory, right? So this is how to find this systems, either causal, non-causal, etc. So standard procedures. So do the practice, then you can easily tell by looking the equation itself. So I'm giving a assignment for you, already given in the problem sheet. You can go for y of n is equal to x of 4n plus 1. Now by looking this, I can make 2-3 comments directly, or all. The moment it is scaling is there, right? We can say it is with memory, because y of 0, it is depending on the 1. So it is with memory or not a memoryless system. So with memory is over 1 over. Now the moment it is scaling factor is there, we can say it is a time variant. So there is no doubt it is a linear, right? So you can go with the procedure, you will get the linear only. Now, so is it a stable or unstable? Directly stable, because if you give the bounded input, you will get bounded output, because it is directly proportional, right? So stable is over. Now it is a causal or non-causal. Suppose if I substitute y of 1, we will get x of 4 into 1, 4 plus 1, so we will get 5. So present depends on the future, so directly non-causal system, right? So the moment scaling is there, so it is time invariant as well as non-causal, right? So this is how to proceed for this finding the stability and unstable systems, right? So I hope you got some basic idea how to do the problems. If you are having any doubt, please post a comment.